So in this video, we're going to talk about how to solve problems involving exponential growth and decay. So a negative exponent is going to indicate a reciprocal. Remember, if you have a to the negative n, that means we have 1 over a to the n. And if we have 1 over a to the negative n, that is a to the n. So let's rewrite these fractions without negative exponents. So we have 3/5 to the negative 1. So if I rewrite that as the reciprocal, I can have 5/3, and then that exponent will become positive. So 5/3 to the 1 will equal 5/3. So what if we have 10 over 7 to the negative 1? If we rewrite that, we get 7 over 10 to the positive 1, and that equals 7 over 10. If I have 8 over 9 to the negative 1, I can rewrite that as the reciprocal, and that'll take care of that negative exponent. So I have 9 over 8 to the 1, and that just equals 9 over 8. So exponential functions written in the form y equals a times b to the x may be classified as exponential growth or exponential decay depending on the value of b. So exponential equations have the general form y equals a times b to the x, where a is the initial value. So it's kind of like the starting point of your function. B is the rate of change, and it represents exponential growth when b is bigger than 1, and exponential decay when b is less than 1. Notice that it's an exponential equation because the variable is in the exponent. So in exponential growth, you have a b that's bigger than 1. So for example, we have the function f of x equals 3 to the x. So if we think about this function in terms of a and b, our a value is actually going to be 1, right? So a is 1, b is 3, so we have b, which is 3, and that is bigger than 1, so that's why we have exponential growth. Notice how the shape of the curve looks in this exponential growth function. If we look at the table of values, we'll notice that as x increases, the y values also increase in an exponential growth function. So if we have exponential decay, the value of b is going to be between 0 and 1. So for example, we have f of x equals 1/3 to the x. So if we describe this function in terms of a and b, our a value is 1, and our b value is 1/3. So we have 1/3, and that is a value that is between 0 and 1, so that is going to be exponential decay. So notice how the shape of the graph looks in this function. So if we look at the table of values, notice that as x increases, the y values also decrease. Okay, so that's something that's going to happen in an exponential decay function. So do these equations represent exponential growth or decay? So remember, the main idea here is going to be if b is bigger than 1, we have exponential growth. If b is between 0 and 1, we have exponential decay. So here, all we need to look at is the b value. Okay, so we have b, which is 6 over 7. If you want to convert that to a decimal, that is about 0.857. Okay, that's between 0 and 1, so this one is going to be decay. In A, we have 0.76, which is our value of b, and that is going to be, once again, exponential decay, because that's between 0 and 1. In C, we have 5 over 4. If you'd like to convert these to decimals to figure out what the values are, you can go ahead and do that. So you have 1.25. Well, that is greater than 1, so we're going to have exponential growth. Okay, so notice that I'm only looking at the values of B. The values of A don't matter when you're trying to determine exponential growth or decay. So here we have 2 times 1.52 to the x. So that is a value that is bigger than 1. So that is going to be exponential growth. Here we have 3 times 1 to the x. Okay, so when it's 1, it's actually neither. Okay, our b value is exactly equal to 1. And notice that it doesn't fall into growth or decay. For it to be growth, it has to be bigger than 1. For it to be decay, it has to be less than 1. Okay, so when it's exactly 1, it's actually neither exponential growth nor decay. So exponential growth and decay are based on exponential equations in the form y equals a times b to the x. So sometimes you have to adjust an equation to rewrite it in this form. Because notice in exponential equation form, we have that x by itself as the exponent. Okay, so we don't want to have anything else with that exponent. So let's think about this equation and think about whether it represents exponential growth or decay. So remember, to figure that out, I need it to be in this form y equals a times b to the x. Well, look here, I have a negative x, right? So I need to do a little bit of rearranging to get this into y equals ab to the x form. So what I need to do is I need to make that look like x. Well, what I'm going to do is I'm going to use this idea. Well, I'm going to say, well, negative x equals negative 1 times x, right? So remember, I can use that power property. Remember, we have that property of exponents when you have a to the m raised to the n, that is a to the m times n, okay? So I'm going to kind of use that property backwards to rewrite this equation. So I'm going to say that this is y equals 3 over 2, and then that 3 over 2 is being raised to the negative 1, and that's being raised to the x, okay? So I'm saying that this is like a power of a power, because remember, when I have a power of a power, I just multiply together the exponents. Okay, so now I can work on simplifying this. So on the inside, I have 3 over 2 to the negative 1. Well, remember, we talked about those negative exponents as being reciprocals, right? So this is basically like 2 over 3 to the first power, and then it's being raised to the x. Okay, well, 2 over 3 to the 1 is just 2 over 3. So this is basically just 2 over 3 to the x. Okay, so now my function is finally in the correct form, right? It's an a times b to the x form, right? Because I have x by itself. So this 2 over 3, if you remember, that is 0.667. So this is basically 0.667 to the x. And notice that number is less than 1, okay? So this is going to be an exponential decay function. So the important thing I want to point out here is you can't look at an equation and determine if it's growth or decay unless it is in the correct form. So now you can go ahead and pause the video and try this example on your own. So here we have 2/5 to the negative 2x. So I'm going to use that same idea, okay? I'm going to use that power of a power property, and I'm going to use it backwards to write this as negative 2 times x. So I have 2/5 to the negative 2, and remember, to get rid of that negative exponent, I can just take the reciprocal. So I have 5 over 2 to the 2, and then raised to the x. So remember, when you have a quotient and you have a power, that exponent is going to go to both terms. So I have 5 squared over 2 squared, and that's all being raised to the x. So that's 25 over 4 to the x. 25 over 4 is 6.25. So the correct form of this function, right, when it's in y equals ab to the x form, that's y equals 6.25 to the x. 6.25 is greater than 1, so we have exponential growth. So in summary, remember that an exponential equation in the form y equals ab to the x represents exponential growth if b is bigger than 1. It represents exponential decay if b is between 0 and 1.